Hello class, in this video I'll be showing you how to find the derivative of the exponential function e and how it applies to a business scenario. Let's begin. And before we find the derivative of the function e, let's be reminded about what e is. E is an irrational number. Which means e cannot be written as a fraction with integer parts. And e is equal to 2.71828 ... So if we write f of x is equal to e of x, that is approximately 2.71828 raised to the x power. And how do we find the derivative of e to the x? Well, if f of x is equal to e to the x, then the derivative, hold on here, the derivative is e to the x. So the derivative of e to the x is itself just e to the x. And the chain rule version for the derivative of e to the x is the following. If f of x is equal to e raised to the g of x, then the derivative is e to the g of x times the derivative of g of x. Now let's go ahead and answer the following question using our brand new rules. It says the total sales of a new personal computer in thousands is given by S of t, where t represents time in years. Find the instantaneous rate of change of sales at t is equal to 1 year and t is equal to 5 years. So we don't see the word marginal anywhere, but we do see the word instantaneous rate of change. And when a problem asks for instantaneous rate of change, that is measured by taking the derivative. So S of t consists of two terms, and we will take the derivative of each term separately. So the derivative of 100t is 100. Now we need to figure out what is the derivative of e raised to the negative 0.32 power. Well, I'm going to do that over here on the side. And if we look at the chain rule version for the function e raised to the g power, in this case, g of t is equal to negative 0.3 t, so the derivative of t is negative 0.3. So the derivative of f with respect to t is e to the negative 0.3 t times negative 0.3. And that's what goes in the brackets right here. So the derivative of s with respect to t is 100 plus 27 e to the negative 0.3 t. Now the problem asks to evaluate this derivative when t is 1. So we're going to do that in Decimus. Okay, so if you want to find e, go hit the ABC, type in e, and that will give you the proper value for e. And we want to raise that to the negative 0.3x. Now we want to evaluate this derivative when x is 1. And so that's 120.002, so we'll round that to 120. And now we want to evaluate the derivative when t is 5. So going back to Decimus, and that's 106.024 or 025. Okay. Interpret your results from part B. Okay, so the value that's given is the value of a derivative, which represents change. So what that means is that if time increases from 5 years to 6 years, total sales of a new computer will increase by approximately 106.025 thousand. Now I write thousand there because total sales is in thousands, so we have to have the thousand.